Let me open the transfer table. Just a second, please. Transformation table. You can write one more formula in your formula sheet, which is this.
Okay.
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 Let me see what we are. Is there anything else or not? I've already told you one more that if we have Tn e to the power minus 80 u of t, what was that? Do you remember?
TM or TN?
Tn. You can take anything if you want to take m. It is a just constant number. Okay. So this
Yeah,
is
it's n factorial n plus 1. Yeah.
okay. So we have these and okay, let's just solve one question. Let's see, are you able to do it or not? Can you tell me here? And
Yeah, so
here also.
24 is the omega.
I always told you that you have always to check. How will you check? How will you determine the values? You will always check the denominator. Okay, because there could be, suppose here I am taking one value. If suppose there is a, so it would be a omega, right?
Yeah, it's 2 omega then.
Suppose I am writing here, it is, here I give you value 24, so here it would be 24 omega.
Yeah.
Okay, so always check the values from the denominator, not from the numerator. What is the formula? Let me tell you. Formula is omega upon s plus a whole square plus omega square. Now tell me. Let's just remove.
Omega
Right.
is 24.
Wrong again. What did I tell you just right now? Always check, compare the denominator part. Why are you seeing omega as 24?
Or then omega is 16.
Omega is 16. You will compare s plus 2 whole square plus 16 as s plus a whole square plus omega square. So you got a equal to 2 and omega square is 16. Where do you see here we have omega square, right? Not omega.
Yeah.
So we will have omega is equal to 4. Okay, is it fine?
Yeah.
So value of omega is 4. And what is this? It is e to the power minus 80 sine omega t. So here you have 4, right?
Hmm.
So what will you do? You have to bring omega here also, right? To make this thing equivalent to this, you need omega here. So
Yeah.
what will you do? You just divide and multiply with 4. Okay,
Okay.
fine.
Yeah.
Now what do you see? This whole term is nothing but this, right?
Hmm.
You can write like this also. that 4 upon s plus 2 whole square plus omega square. Sorry, 16. Or 4 square. Okay?
Yeah.
You can write like this. Now this is nothing but 6.
Yeah.
So you got, and what is this? This is equivalent to omega by s plus a whole square plus omega square. So
Yeah.
what you got? You got 6 e to the power minus 2t sine 4t. Okay?
The above 4 is supposed to be 16, right?
This is 6, right?
No, not this one. The 4 over s plus 2.
Here.
4 above.
Yeah.
No.
Hmm.
Denominator of s plus 2 whole square plus 4 square.
Yes.
The value above it. Do you see it 4?
Yes.
Yeah. This is supposed to be 16, not 4.
Why 16? What is this here? Is this omega square or omega?
Oh, this is omega, then the value down.
Here?
Yeah, how this is 4 square,
I
the above is 4.
Okay. 4 square is what? 16, right?
Yeah.
Here, what is the value? This is omega square. What is the value of omega? 4 square.
Oh, okay.
Okay. Let me give you one more example and let's see.
No,
Do
no,
you?
I need to study it really.
Okay.
I won't remember like this.
Okay. I'm giving you one example. Do it as a homework. Okay. And
Okay.
check whether you understand it or not. Or you can take more. This is your these two, solve them. Okay. And
Oh,
solve
all
all.
right, if I have really time.
It will not take very much time. See, Nawaf, if you will not practice questions, you will not get it. Okay. So you need to practice. Otherwise, you will always get confused. You cannot do questions in your exam do only by practicing one question, right?
Okay.
These three questions, do it. Okay.
Okay.
And I was giving you one more example to do here. 24 upon s plus 2, 5. Tell me for this. Let's take it on another page. 24 upon s plus 5 whole square. Or do one thing, do this example also. Okay, because I have already told you, if you are able to do it by your own, then we can move to the next question. We do not need to do other questions related to this. Okay.
Okay.
I have already told you these are the formulas. Always compare, always compare denominator.
Okay. Denominator is the one down, right?
Yes, always compare denominator, then only, because here you can have a value. Okay. Now how will you find a? Right?
Okay, let's jump to the new stuff.
Yeah, just a second, let me open the file.
Okay.
Can you see the file? Can you see? Hello? Hello? Nawaf? Hello?
Yeah, just a second, please. Just a second, Moini.
No problem.
Yeah, I'm here, sorry.
So, can you see this PPT?
Yeah, I can.
So this thing I already told you that if you have what is your transfer function?
Yeah,
Transfer function.
let's do it again because I erased all the videos.
So transfer function is nothing but output upon input, right?
Mhm.
And what is our output? We say that output is our, this is suppose this is
Yeah.
your system and we are giving
This, yeah.
and this is C of t. Okay, so this system will have some transfer function which we denote by G of S. Okay, if we talk about R of t and C of t in in S domain, so we call them R of S and C of S. So what is the relation between them? It is C of S upon R of S, right?
Yeah.
So this. And we can say that our output is what? Transfer function into input. Okay.
Okay.
And the zeros and poles. What are zeros and what are the poles? Suppose we have suppose we have some transfer function as s plus 2, s plus 4, s minus 6 upon s plus 1, s plus 3, s minus 5. Okay.
Mhm.
So these, what are these? These are your roots, right?
Yeah.
Roots. So the numerator part, these numerator part roots, we call them zeros. And denominator parts roots, we call them poles.
Okay.
Numerator part, zeros. Denominator part, poles.
Yeah.
Right? So can you find the zeros? Zeros location? Zeros location are at, we what do we do? We compare them with 0, right? S plus 2 is 0. So this is S is equal to minus 2.
Yeah. And S equal -4 and S equal +6.
Yes. And what are the location of poles?
S equal -1, S equal -3, S equal +5.
Yes. So when we will plot it, this is your imaginary axis and this is your real axis. Okay, this is your positive plus side and this is your negative side, right?
Yeah.
As we do on the scale. So and we denote our zeros by circle and poles with cross sign. Okay, so can we see what are the location of zeros? -2, -4 and 6. So suppose this is -2, this is -4 and this is your 6
Okay.
and this is your 5 and this is your -1, and this is your -3. So zeros location are -2, -4, and 6. That means
Circle.
this, and this. What are the location of poles? -1, -3, and 5. So
Uh,
cross sign here, cross sign here, and cross sign here. Okay.
yeah.
Suppose you have poles
Do we have to
location.
connect them at the end or no?
I'm sorry, what?
Do we connect them at the end?
Do you what? I'm not understanding. What are you saying?
Do we connect the X's and O's at the end?
You mean this?
Yeah. Do we connect them?
Yeah, you can make there's no problem. Okay. So suppose your poles location are at ±4j. Okay. And zeros location are at -3 ±5j. So how will you plot? This is your real axis. This is your imaginary axis. So this is your j axis, right? Imaginary is j. So ±4j means, suppose this is your 4j. This is your 4j, and this is your -4j. Okay.
Yeah.
And -3 ±4 5j means this is your -3, and this point is your 5j, and this is -5j. So the poles location are at ±4j means this here. Zeros location are at -3 and ±5j. So what is this location? This location is this, right? So we will make a circle here, and we will make a circle. Okay.
Okay.
So zeros always from the numerator, and poles always from the denominator.
And poles with X and zeros with O.
Yeah. Okay. These things I already told you.
Okay. And do you have
Now,
an example to give me
like
like
this
this?
is easy. I already gave you. You can take any value.
Okay.
Okay.
Just give me any value then. I would do as homework.
Let me not give you like that. Let me give you g of s is x square plus 6s 6s plus not 6s plus 7 s square plus 7s plus 10 s square plus 2s plus 5 s square plus you will have here 4s plus 4, and here you have s square plus 6s plus 9. Okay, one more thing. Suppose you have location -3 and -3. Okay, these are your poles location. So what will you do? Or take -5 and -5. So this is your -5, and this is your pole. So what will you do? You will just double cross. You will make cross number of times as many as you have root location. Okay.
Okay.
So question. Okay, later. Fine.
Okay.
Mm, Now this is the partial fraction, very easy partial fraction you can do.
Sorry?
This can you see the PPT?
No.
now?
No.
You can't see the PPT.
Oh. I see the whiteboard.
Okay, wait. Now?
Yeah.
Okay, so I'm telling you that you have already, this is, okay, let me give you one thing more here. In this question, you have been given G of S, okay?
Mhm.
And you have been given that your input is unit step function. What means unit step function? Unit step is this. So what is the, what will be its value in your X domain? 1 by S, right? And
Yeah.
you have to find system response. What is response? Response is nothing but output. You have to find that. Okay. So you know R of S, you know G of S. You have to find C of S. So I told you that C of S nothing but R of S.
R of S multiplied G of S.
So this will be S, S plus 2, S plus 5. Now you can, this is nothing but partial fraction, very easy partial fraction. You can do it by yourself. Okay.
Let's do it because I'm lost.
Here, how will you do? S plus 2 upon S, S plus 5, right? You will say A upon S plus B upon S plus 5.
Yeah, but a step function means 1 over S, right?
Yes,
So how did we get S2, S plus 2 in the above?
this is your G of S. G of S is S plus 2 upon S plus 5. R of S is 1 by S. C of S is R into G. Okay.
Okay,
So it's 1 by S into S plus 2 upon S plus 5. You can write like this.
okay.
Now this is the case 1. Can you solve it?
Yeah.
Okay. Already told you. Nothing new yet. Here, whenever you will have your output system response. Okay.
Mm-hmm.
So your response is made up of two things. First is forced response and second is natural response. Okay.
Okay.
How do you get forced response? By using input pole. Input pole generates the forced response and system poles generate the natural response. What does it mean by? Suppose you had in the previous example S plus 2 and S plus 5. This was G of S and R of S was 1 by S. Okay. So here if you see for input what poles you have? You have pole at S is equal to 0, right?
Yeah.
So this will generate your forced response. Okay.
Mhm.
Input, this is your input pole and this input pole will generate your forced response. And if you see G of S is the transfer function of a system. And what is pole here? What is the location of poles here? S is equal to -5. So this pole will generate natural response.
So if it's a 0, then 4.
No, it could be anything. I am telling you that input pole, this is your input pole. Okay.
Oh,
Input generates force response and system poles will generate natural response.
okay.
So your final response, whatever your final response, it is of made up of two things, sum of two things, natural response plus force response.
Yeah.
How do you get natural? You get natural from system poles. And how do you get false? You get it from input false.
Yeah.
This is again the same question. This is 1 by s. You will multiply it with and you can solve. This is your homework. Try to do by your own. Okay.
Okay. Then just partial fraction, right?
And simple case 1 partial fraction.
Okay.
Now moving to this. You know order of a system. Order is nothing but a highest degree in your differential equation,
Yeah.
right? So if suppose you have d square y by dt square plus 2 dy by dt equal to 0. So here, what is the highest degree? Highest degree is 2. And highest degree is nothing but a order.
So,
Okay,
mhm.
it's fine. And I already told you one thing, that in a proper system, system order is defined as a degree of the denominator polynomial. Suppose you have s upon s square plus 2s plus 1. So what will you say? What is the order?
Uh, 2.
Yes, 2. Suppose you have s plus s square plus 4 plus s plus 1 and s square plus 2s plus 1. What is the degree? What is the
Yeah.
order? Order is still 2 because you always check it from the degree of the denominator polynomial.
Mhm.
Moving to this question. First order system means in differential equation you have what? You have order 1, right?
Yeah.
Order is 1. Means, so here we have assumed that suppose our g of s is nothing but a upon s plus a, right? Okay.
Mhm.
This
Yeah.
is this is general for transfer function for first order system. Do you see orange color or should I change it?
Could you change it, please?
Tell me which one.
The other one.
Black?
Do green, maybe green.
Okay, green. You can't see green. Let me take black. Okay. I was not taking black because your screen is also, the thing which is written is also in black. Brown is okay, right?
Okay.
So I told you that g of s is it clear now?
Yeah.
Okay. So this is first order system
Mhm.
transfer function. What is it? A upon s plus a. Okay. This is the general case. Now what input I am giving? I am giving input as 1 by s. 1 by s is what? Unit step, right?
Yeah.
And one more thing. Here it is written step response. What does it mean? Suppose you have in your question, you have been given that g of s is k upon s plus 4. Okay. And find a step response. So you will say that Mohini, I don't know what is the input. You haven't given me because c of s is r of s into g of s,
Yeah.
right? To find C of S, you need two values. And you did not give me the value of R of S, right? So how will you find R of S? This word. Okay.
Okay.
Here is given a step response. Step response you will get only.
One over S.
Yes, step response means your input is input is unit step, and you have to find response for that. Response or output for that. Okay.
Okay.
Suppose you have been given that find impulse response. That means your input is your R of t is impulse function. Okay.
Okay.
Suppose it is written ramp response. That means your R of t is tu of t. Okay, ramp function.
Okay.
So here R of s is 1 by s, g of s is a upon s plus a. So C of s would be 1 by s into a upon s plus a. It would be a upon s into s plus a, right?
Mm-hmm.
Now you will use case 1. You can find it easily. When you will find, you will get 1 minus e to the power minus at. Okay, this is in C of t term. And in C of s, you will get 1 by s minus 1 upon s plus a. Okay,
Good.
now you know this pole s is equal to 0 pole is due to the step your input poles, right?
Mm-hmm.
And this pole is from the system pole.
Yeah.
That means this thing is giving you forced response and this part is giving you natural response.
Natural response. Yeah.
Now moving to this. Okay. So what is the time constant? Time constant is nothing. It is the time for the response to rise to 63% of its final value. Okay, you have to memorize this. Time constant is that time at which your response rises to 63% of its final value. Okay,
Time constant.
yeah,
Okay.
1 second, yeah, okay. This part is very important. And rise time is what? Rise time is it is the time taken by your response to reach from 10% of final value to 90% of its final value. Okay.
Okay.
And what is the formula? You can write this in your PDF. This is TR is equal to 2.2a, 2.2 by a. Okay, this is your rise time. And what is time constant? It is 1 by a. Okay,
Okay.
is it fine?
Yeah.
And this is your time constant. So if you put here, you can say your time rise time is nothing but 2.2 t, right?
Mm.
Because this is 2.2 by a and 1 by a is t. So you can write 2.2 t. Okay. And
Where
this
did you see him exactly? I don't see your mouse.
now can you see?
Yeah, but little while ago I didn't see what you pointing at.
Okay. So I'm saying TR is equal to 2.2 a. Okay.
Hmm.
Is it fine?
Yeah.
T is equal to 1 by a. So you can write TR is equal to 2.2 t also, right? Okay.
Yeah. Wait.
Now what? Uh,
Yeah. You can write. Yeah.
what is the settling time? It is the time for the response to reach and stay within 2% of its final value. Suppose you have this is your final value, A, okay?
Mm.
And your system response is moving like this and getting here. So you can see that it is approaching its final value, right? Here, somewhere here. And this is within 2% level, okay?
Mm.
So that time is called your TS, settling time. If you see here, this time constant is what? Time response should reach 63% of its final value, means 0.63, right? 63 by 100 is 0.63. So if you see, this is 0.63. I draw here and this is my graph, okay?
Yeah.
And this is 0.3. I extend this line cuts here, I drop a line here, and this part is your, so This total part is your time constant. Okay, this is your time constant. Okay,
Okay.
next part, that rise time is time reach for the waveform to go from point 1 to point 9, right?
Mm-hmm.
So this is your point 1 and this is your point 9. So you drop it here and you drop it here. So this total interval is your rise time. Focus here focus here, okay? Because you can be in your exam, he can give you the graph and ask you questions.
Okay.
Okay, so this is your rise time. And what is your settling time? Settling time is Ts by 4 by A when it reaches the response to and stay within 0.2% of its final value. Means what is the error we are getting? 0.02. That means what steady value should reach? 1 minus 0.02 is 0.98. Okay,
Mhm.
so this is 0.98. Suppose this is your 0.98. Okay, drop here. So this whole portion is your TS. Okay,
Mm-hmm.
so write in your formula sheet, write a one thing T is equal to 1 by A. Okay, another TR is equal to 2.2 by A and TS is equal to 4 by A, or you can write that 2.2T and this is 4T. And what is the, if your G of S, you should write this also, otherwise you will ask how did I get A value. Okay,
Okay.
and your C of T is 1 minus e to the power minus 80,
Yeah.
right? So this A value is here. This A value is, you can write like this also, T by tau. Okay,
Mm-hmm.
so here your tau value is tau or T, anything. It is 1 by A. Okay,
Okay.
now suppose in this question you have been given this G of S is equal to K upon S by A. Okay,
Mm-hmm.
G of S is K upon S plus A.
Yeah.
Now, and we have to find a step response. Step response is K
Over
S.
S.
Okay, so what did I get? We will get K by A 1 minus e to the power minus 80. This is your, when you will solve it, you will get this. Okay, fine.
How did you decide it's 1 minus e to the minus 80?
When you will solve it using case 1, you will get this. Okay,
So how did you do it? Could you just do case 1 and not throw some number over there?
okay. This is K by A minus K by A upon S plus A. Okay,
Mm-hmm.
so 1 by S is what? U of T.
Yeah.
1 by S plus A is what? E to the power minus 80 U of T. So what will you write? K by A 1 minus e to the power minus 80, right? U of T.
Yeah, okay, okay.
So here you got this. Now you have to identify what is the value of K here and A here. So you see, you know that T is what? 1 by A, right? Right?
Yeah.
And T is your time constant.
Mm-hmm.
What is the definition of time constant? It is the time taken by the response to reach 6.63% of its final value.
Yeah.
0.63 of its final value. final value, right?
Yeah.
Now, if you see, this is suppose okay. 0.63 of the final value, okay. So here, if you see from this graph, you see that final value is your this, right? This is your final value,
Mm-hmm.
which is here your 0.72. Okay.
Yeah.
So find 0.63 of 0.72 is what? Find it. Okay. So you will, when you will multiply 0.63 into 0.72, you will get 0.45 value. Okay.
You will get what?
0.45.
Oh, okay.
Okay. Now here you what does it mean? That when the time at which the time taken by the response to reach 0.45 value is your time constant. Listen very carefully, okay?
I did understand here.
Let me go back. What is the you need to understand all the definitions I told you to solve this question, otherwise you will not be able to. Okay. What is time constant? Time constant is the time taken by response to reach 63% of its final value. Okay.
Okay.
When you plot this graph, this is your final value, right? This straight line is your final value.
Yeah.
Okay. Here, if you check this graph, you see that this is your line. This your graph is approaching this value. So final value is what? It is given as 0.72.
Yeah.
Okay. What is, so you got final value now. What is the final value? Final value is nothing but 0.72. Now you have to find time constant, right?
Yeah.
How will you find time constant? It is 63% of its final value, means 63 upon 100 into 0.72. When you solve it, you get 0.45. Okay.
Okay.
So time taken by the response to reach 0.45 value is your time constant. Okay. So now when you see this graph, this is your graph. Okay.
Mm-hmm.
And when you see that this is your 0.45. Now just drop a line here, extend a line. This line cuts here. So drop this line here. Okay.
Mm-hmm.
Now this value is nothing but your time constant. Okay.
Okay.
So you get here that this is your 0.13 second. Time constant is nothing but 0.13 seconds. You found it. Okay. Everything is clear now.
Yeah.
Now T is 0.13. What do you know? T is equal to 1 by A.
Yeah.
A is 1 by T. That means 1 by 0.13. So it is 7.7 hertz. Okay.
Mm-hmm.
Now you have to find K by A, where you have to find the value of K also. How will you find? You know what is the final value you got here. Here you get K by A 1 minus e to the power minus 80, right? So this amplitude is always your final value. Okay, always it is your final value,
Okay.
right? So, and from this graph, what is your final value?
0.7.
Yeah, so K by A is 0.72. K is 0.72 A, so it would be 5.54. Okay,
Oh, okay.
so what you have to find G of S. So G of S is nothing. K value is 5.54 upon S plus 7.7. right?
Mm-hmm.
Is it fine, everything?
Yeah.
Now moving on to the second order system. Second order system means what is your order?
You have S square.
Yes. So here you can see that this is your second order system. Okay. Okay. You can see the whiteboard.
Yes.
So here, now we will talk about second order system. Second order system means G of S would be, you remember this, omega n square upon S square plus 2 zeta omega ns plus omega n square. Okay. What is omega n? It is your undamped frequency, natural frequency. Okay.
Okay.
What is undamped natural frequency? Suppose you have sine omega t. So this your graph look like this, right? So there is no damping. What do you mean by damping? Damping means, see, if you see here, there are many oscillations, right? They are jumping from up and down. Okay.
Yeah.
What do we call them? We call them oscillations, right?
Okay.
But when we set our plant in an industry, we do not want oscillations. Okay, so to reduce the amplitude of oscillation, we use a factor called zeta, which is called as damping ratio. Okay, so damping is nothing. Damp means what? To reduction, right? Damp means reduce, to reduce.
Okay.
So you are reducing the or nullifying effects of oscillation. Okay, how do you do that? By using this factor which is called zeta. Okay,
Okay.
and your what do you say? This your signal. This signal has some omega frequency, right?
Mm.
This omega is nothing but undamped. Okay, suppose this uh, pulse mm, looks like this. That means here you have damped its oscillation. Okay.
Okay.
Now zeta value can be of many types. Suppose, so first of all, that we always take for zeta greater than 0. This is you called as positive damping. Okay. So there are many cases. First case is if zeta is between 0 and 1. So you call them as underdamped.
Okay.
You have one condition, zeta is equal to 1, which is called as critically damped. Another condition you have zeta greater than damped, this means over damping. Okay, as you see that as you are increasing the value of zeta, your oscillations in the systems are getting decreased. Okay, this is the effect of a damping ratio. Fine. If it is between 0 to 1, you say that you have it is under dam system, and there will be some oscillation, but less than the original one. Okay.
Yeah.
Now see, I told you that G of S is omega n square upon s square plus 2 zeta omega ns plus omega n square.
Mhm.
Now here, what is the poles? If you find poles here, so you will find that s is equal to minus 2 zeta omega ns plus minus under root b square. What is the formula? Minus b plus minus b square minus 4ac by 2a, right?
Yeah.
So this is 4 zeta square n square minus 4 omega n square upon 2. When you solve it, you can take 4 omega n square common, right? And when you do under root, so you will have 2 omega n under root zeta square minus 1 upon 2. So you will have poles as, and since you have order 2, so you will means you will have 2 poles, right?
Mm-hmm.
So it will be minus zeta omega n plus minus omega n under root zeta square minus 1. Okay.
Okay.
Now here we will play these things. This is your poles of, or you can say that closed loop poles of your second order system.
Mm-hmm. How many order are there?
For only first and two, first and second.
Okay.
Okay. So now your poles are minus zeta omega n plus minus omega n under root zeta square minus 1. Let's take case 1. What is the case 1? When your zeta is between 0 to 1. Okay.
Mhm.
So now when you put it here, you see, suppose your zeta is 0.5. So when you will put here omega n under root zeta square minus 1, this is 0.5 whole square minus 1, right? So this value will, when you will solve, you will get negative value, right?
Yeah.
And negative under root is what? J,
Yeah.
right?
Yeah.
So you can write them as minus zeta omega n plus minus j omega n under root 1 minus zeta square. Because what are you doing? You are doing zeta square minus 1. And since take common here, minus 1 under root is what? J omega n under root 1 minus zeta square, right?
Yeah.
Now, these are your poles for this case. So what will be your output? Your output, and one more thing. Here you call zeta omega n as alpha, and omega d is omega n under root 1 minus zeta square. Your omega d is your damped frequency. Okay. And alpha is your damping factor. Right. So you can write here minus alpha plus minus j omega d. So what will be your output? Output will be your C1 e to the power minus alpha t C1 cos omega dt plus C2 sin omega dt. Okay.
Okay.
And how will your response look like? It would be something like, if it is a, it will look like this. Okay.
Okay.
This is the case for under damping.
Mm-hmm.
Now case 2, when your zeta equal to 1. Now put the values here. Minus zeta omega 1 plus minus omega n zeta square minus 1. When you put value here, you will get minus 1 here, right? Because this would be 0. 1 minus 1 is 0.
Yeah.
So here you have two poles. S is equal to at omega minus 1 n and minus 1. Okay. So what will be your output? Output will be your C1
minus
plus C2
n or minus 1.
e to the power where minus omega n minus omega n. Okay.
Okay.
And this you called as critical damping. Okay.
Okay.
I give me a second, please.
On which page we are? Huh?
Wait, 1 second. 1 second. We are almost on the end of the slide. Just a second.
And of 4-1 or 4-2?
1. Okay. So here we got this part. Now let's see. Yeah, you can see the whiteboard, right?
Yeah.
And now case 3 is when zeta is greater than 1. So here this is nothing but minus zeta omega n plus minus omega n zeta square minus 1, right? And since here you can see that these are real and distinct poles, right? Because zeta value is greater than 1. So you will have a real value only. Okay.
Mm-hmm.
So you can say minus alpha plus minus omega d. So here you have minus alpha minus omega d and minus alpha plus omega d. So what the value will have, you will here your output will be C1 e to the power, you can say S1t plus C2 S2t. What are the value of S1? S1 is this and S2 is this. Okay.
Okay.
And how does it look like? Okay, I for here this is your case for zeta is equal to 1. And how it will look like here? It will look like something like this. This is your zeta greater than 1. Okay.
Okay.
So we studied three cases here. Let me go to the time response one. Okay. Can you see the PPT?
Not really, no. Oh yeah, I can
Can you
see.
see the PPT?
Yeah.
Okay. So here you can see that we already discussed every part. Overdamped means large amount of energy absorption. Okay. And underdamped, we discussed this part. For undamped, okay, there is one more case I forgot. Wait. This is your case 3 and case 4 is here one more case. This is your undamped. Okay. So here if you see case 4 zeta is equal to 0. So S12 is minus zeta omega n plus minus omega n under root zeta square minus 1. Here I wrote one thing wrong. Here it would be, no, it is right. Okay. So here when you solve it, you will get here plus minus j omega n. Why plus minus j omega n? This would be 0. And here when you will put, you will have minus 1, right? And minus 1 is what? Plus minus j omega n, right?
Yeah.
Okay. So your case would be here C1 cos omega nt plus C2 sin omega nt, and your graph will look like this. Okay.
Alright.
And how will you define the pole location? here if you see, you have complex poles. So when you will plot it, you will have this kind of plot for underdamping. Okay. For case 2, here you have real and equal roots. Right? So here you will have this kind of pole location. Okay.
Mm-hmm.
Here you have real and distinct poles. So it would be S1 here, S2 here, like this. And here you have in case 4, you have imaginary poles. So how will you draw?
How do you
It would
know?
be like this.
How do you know it's gonna be imaginary or?
This is j omega n. It means it is going to lie on imaginary axis, right? We just discussed it.
All right, all right.
We got this value. Okay. We got j omega n, right?
Yeah.
So j omega is going to lie here only, right?
Mm-hmm.
And here, yeah, here it is real and distinct poles. Real and different. Distinct is what? Different.
Yeah.
So the real axis is this, and they are going to be different. So it could be, it could lie anywhere on real axis, right?
Mm-hmm.
Now in case 2, you have real and equal roots. So definitely they are gonna lie on the real axis, right? And since they have minus sign, so that definitely they are going on to the left hand side, right?
Mm-hmm.
And they are, since they are equal, so they will lie on each other. Okay.
Mm-hmm.
And here you have complex poles. You have real part also, imaginary part also. So it would something, it will lie like this.
Okay, so case one is always like this.
Yes.
Mhm.
Case 1 will always like this, case 2 will always like this, case 3 will always like this, case 4 is always like this.
Okay. And is there a question on the exam? Do you think, like telling me, oh hey, which case is that?
Yeah, so it is very easy to find. If you see that they are complex, suppose they have given this, okay, and they ask you which it is under damping, undamped, critical damping, or over damping. You can know that since it is complex pole, so definitely it is going to be a case 1. Okay.
Okay. And let's say if it's case two, what should it be?
Case 2, it will be like this: real and equal roots. That means uncritical damping. Okay.
Okay.
They are fixed for each one. They will not change. If real and equal roots, that means critical damping. If real and distinct, that means it is over damping.
Yeah, I have to study.
Yes. You can write these things. Okay, here you can, that if it is, suppose underdamped means complex roots. Critically damped means equal, real and equal roots. Overdamping means real and distinct roots. Okay. Undamped means real, uh, what, imaginary, sorry. Here we will have imaginary. Purely imaginary roots.
Mm-hmm.
Okay. You can write. Now moving to your PDF. Can you see this?
Yes.
See here. Here they have written that for overdamping, here it is not written. For underdamping, you have real part. Here, this is, see, this is complex roots, right? Here you have real and distinct root. For undamped, your poles are purely imaginary. And for critically damped, they are repeated purely real. Okay.
Okay.
And you can say this is very important line. I have seen many questions on
On what?
this line. Critically damped, faster response without overshoot. Suppose, and I think this is I don't know, maybe I have done questions from your university only. It will be, there could be a question that find something, find zeta value who has fastest response. Okay,
Mm-hmm.
fastest response without no overshoot, without overshoot. Okay, that means your zeta is 1. They will not, suppose in the question they have given that you have to find omega n value. Okay,
Mm-hmm.
but they also haven't given you zeta value, but they have written that your response is the fastest response without overshoot. So that means whenever it is fastest response, so you will say zeta is equal to 1.
Okay.
Okay, write it in. I think it is the question will come upon this, because I have solved many exams and this question is surely in the control system.
Okay.
Now this is the last slide. Here, as I told you that zeta is equal to no oscillation. This is undamped, means zeta is equal to 0. So maximum oscillations. Okay.
Mm-hmm.
This is your underdamped. This part is your underdamped. So see, as you are here, you will see that as you are increasing zeta, your oscillations are decreasing, right? For underdamped, this is 0 to 1, so it's less oscillation. If you see, if you see critically damped, then again less oscillation, and in overdamped, least oscillation. So suppose if they ask that you want least oscillation or minimum oscillation, so
Then
you will say that it is a case of zeta greater than 1, that means overdamping. Okay.
okay.
And now here I already told you overdam means two real conditions. Underdam means two complex roots. Undam means imaginary roots. Critically dam means repeated real roots. Okay, I told you these conditions also. If you want, you can write them on your formula sheet.
Yeah.
Fine?
Yeah. Are we done now?
Yeah, this slide is completed.
Uh, should yeah. So should we have class tomorrow and leave today the whole day for me just to go
Yeah, sure.
twice or maybe more over what we did?
Yes, sure, no problem. Here, these are the questions you need to solve, okay?
Okay.
These questions, these four, and this one.
Hmm. How much we studied?
I think 1 hour 20 minutes or like something like that. We started at 6:36, right? Yeah, 1 hour 20 minutes.
Then we write it.
Okay, so let's meet this time tomorrow.
Uh, this time tomorrow, yes.
Okay.
Or maybe your morning time. Are you gonna
Okay.
be available?
I will tell you because I have one class with another student. He is also from US.
Okay.
So let
Okay.
me just check
Just
and I will.
tell me, and if you available, then maybe I will just finish everything today.
Okay, okay. I will tell you. Okay.
All right, thank you. And yeah. In the class, I was seeing some gears and some stuff that I didn't understand really. And he said, this is chapter 4. This is coming on the exam. So
Okay.
I think for 2 he meant.
Okay.
We need to study for 2 so slowly
Oh,
because I don't understand anything from it.
no problem. No problem. Just tell me what did you where do you lack and give me the question. See, if you do not practice the questions, you will not get it. Okay, because you understand the concept here, then you have to apply it on the questions. As many as questions you can solve, then only you will be able to do in the exam. Otherwise you will get stuck.
Yeah, yeah,
Okay,
yeah, I'm
so
going.
you have to solve as many as questions you can.
Okay, thank you.
There would be little differences in every question. You need to understand that your professor will not give the same question as he gave in your exam. There will be little bit trick there. Okay, and that thing you can only solve when you will know the concept better, right?
Okay, okay.
So let's meet tomorrow. Bye bye. Good night.
Good night.